All right, in this question number 5 for the SAT problem, um, this is a distance and rate type problem. And it says Perry drove to the zoo at an average speed of 30 miles per hour. He came home the same route and traveled at an average speed of 25 miles per hour. If his total travel time was 2 hours and 12 minutes, how many miles did he drive on his return from the zoo? So basically, if we just take a moment to think about the scenario, Perry leaves his home. Let's say his home is here and he drives to the zoo. And on his drive there, he is traveling 30 miles per hour. And he leaves the zoo and he comes back exactly the same route, except this time he is traveling 25 miles per hour. And the question is, well, how many miles did he drive on his return? So we want to know how many miles was that? Well, you notice that we're talking about miles per hour and we're talking about time, and they're asking for distance. So hopefully this is a clue that we're going to use the distance formula, where distance, let me write it out, distance equals rate times time, or D equals R times T. And so let's just put down the information into the formula to begin with. So let's first look at him driving to the zoo. So his distance would be equal to his rate of 30 miles per hour, and he was traveling for some amount of time because it doesn't say how long. And then on his way home, his distance would be equal to the 25 miles per hour, his rate, times some amount of time as well. And we don't know the times. But they did tell us something about the total travel time. Well, the total travel time would be the combined total of the going to the zoo and then the coming back from the zoo. I know that the total travel time, I'm going to just put TT for total travel, is 2 hours and 12 minutes. We don't generally like to mix up units, so I'm going to say this is 2 hours, and I want to change the 12 minutes into hours. Well, since it's in minutes and I want to turn it into an hour, I have to think how many minutes are in an hour. Well, I'm going to put a plus there, 12 minutes, and I know that there are 60 minutes in 1 hour. So 12 minutes converted into hours would be the same as saying 12 out of the 60 possible minutes. And if we equate that into a decimal, 12 over 60 comes out to be 0.2. So I have 2 hours plus 2/10 or 0.2 of an hour. So the total travel time is 2.2 hours. Okay, and now that I know that, I need to go back to my equation and try to solve. Well, sometimes we find it easy with problems like this to set up a type of box, not actually a box, a series of boxes, where we have talking about the distance, talking about the rate, talking about the time. And in this column, I'm going to talk or write about the to the zoo. And here I'm going to write about from the zoo. Well, I know that the distance that is traveled to the zoo is exactly the same as the distance from the zoo, because remember he traveled the same route. So I'm going to just leave that as a D. I know the rate on the way to the zoo was 30 miles per hour, and I know the rate on the way from the zoo was 25 miles per hour. And I do not know how much time that he traveled to the zoo, but I can say something about the time traveled from the zoo, because I know that the total amount of time he traveled was 2.2 hours. So although I don't know exactly how long it took him to get to the zoo initially, I know that I would have to subtract it from the total amount of time to get the amount of time that he spent coming from the zoo. Okay, so there was a total amount of time of 2.2 hours total. So he used an X amount of that time traveling to the zoo. To find out what was left, I would subtract the amount of time he used going to the zoo from the total amount of time of 2.2 hours that we were given. So why did I do it in the box like this? Well, by putting it in the box like this and thinking, I now have rewritten my two equations in a different way. The to equation becomes the same, 30 times t, but the from equation now becomes 25 times 2.2 minus t. All right, so what good did that do me? I still have two equations and two variables in both equations, and we can't solve for two variables at one time in a single equation. So I go back up and I look and it says, what is the total distance traveled? Somehow I need to solve for one of those equations. So what I'm going to do is I'm going to study these two right here, and I noticed that they have something in common. They both have a d. So if you remember back in algebra, substitution says you can plug in one thing for another, or if you remember from geometry, we said that we can substitute or use transitive property to complete this. It's not technically transitive in this one. So since d equals 30t, and d equals 25 times 2.2 minus t, I can say that 30t must equal the 25 times the quantity 2.2 minus t, because both of them equal d. So I can just kind of cut out this middle piece, right? So I'm using the fact that they both equal the same number to set them equal to each other. Now I have an equation that only has one variable. So I'm just going to solve. I'm going to start off by distributing the 25 to both of the numbers on the inside, and 25 times 2.2 is going to give me 55, and then 25 times t is 25t. Oops. All right, so now to finish solving this out, I am going to add the 25t to both sides. And that's going to give me 55t equals 55. So then I'm going to divide by 55. And I get that t equals 1. So in both of my distance equations, t is going to equal 1. So I'm going to come back up here, and you notice my distance equations right here. So let's come down. So that means distance equals 30 times t, distance equals 25 times 2.2 minus t. Remember, this was the to, and this was the from. So if I plug into t, 30 times 1 is 30. So the distance traveled, the time, was 30 miles, because the time is 1. And then down here, it should be the same thing, because remember, the distance to the zoo and from the zoo should have been the same, but it's a good double check. So 2.2 minus 1 will be 25 here, and then when you fill in, we get 1.2, and 25 times 1.2 is 30. So to answer the question, how long did it take, or how, excuse me, what was the distance traveled to the zoo? The answer is 30 miles. And a good check was that it was also 30 miles coming from the zoo.